For the Electrochem Lab, we're doing part 1. We have varying concentrations of the anode and the cathode, which here are going to be zinc sulfate and copper sulfate solutions. The first thing I'm actually going to do is 1 in 10 serial dilutions for the zinc sulfate and the copper sulfate. I'm going to put 900 microliters of DI water in each one of the dilute tubes. Here is our most concentrated zinc sulfate, 1 molar. This is going to be our stock, so we need no DI water here. Here is our most concentrated copper sulfate. So we are not going to add DI water to each one of those tubes. We're using the P1000 micropipette, and we have it set at 900 microliters. So now we're going to start with the concentrated zinc sulfate. Now the copper sulfates. So starting over here, we have our 1 molar zinc sulfate, and the concentrations, as we move across here, they are diluted by a factor of 10. So the next solution, once we actually do the dilutions, will be 1 times 10 to the negative 1 molar, and so on, all the way through. Here is our most concentrated copper sulfate solution. This one is 1 molar, same thing. We're going to do a serial dilution by a factor of 10 all the way down, where we'll finish with a concentration of 1 times 10 to the negative 6 copper sulfate. So now we are going to do our serial dilution. So remember, we already have 900 microliters, or 0.9 mils, in each one of the test tubes. So we're going to use the P200 micropipette set at 100 microliters. Now we cap and mix. 100 microliters and mix. And so on, all the way down, where we'll finish with a concentration of 1 times 10 to the negative 6. We are again going to do a 1 in 10 serial dilution, where we finish with a concentration of 1 times 10 to the negative 6 molar copper sulfate. Each one of these already has 900 microliters of DI water. So now we're going to take 0.1. Alright, and now we're finishing with our most dilute copper sulfate solution. Now we are all set. So now we are going to record the voltages while we're varying the concentrations of the anode and the cathode. If you look at our table here, we have left the predicted blank for you guys. That is for you to figure out on your own using the Nernst equation. Just remember, when you see the E with the degree sign above, that is standard conditions. That is when the zinc sulfate and the copper sulfate are both at 1 molar. So the E to the degree sign, or E cell, at standard conditions, will be 1.10 volts. You can figure out the rest of the calculations plugging in the different concentrations for the cathode and the anode. But now we are going to get our measured values. So we're starting with the 1 times 10 to the negative 6 molar zinc sulfate. We want to have the anode in the anode, so zinc with zinc, and the copper wire for the cathode. So copper with the copper sulfate. But we do not have a complete cell. We need something to carry the charge, so we are going to use a salt bridge to connect the cell. So we are going to use the salt bridge. Now we need to turn on the voltmeter. So we are going to record the voltage. So now we have it at the right setting for the voltage. And this is nice and easy because we can use the colors. So the copper cathode will go with the red, and the zinc anode with the black. See what we get for voltage. 0.893 volts. So that is the measured voltage. So now we're going to move right down the line. Again, we need to make sure that we have the salt bridge. If you can, try to have these not touch. It's a very small container, so looks like about 0.863 volts. All right, so it looks like the voltage increased. So here we have 1 times 10 to the negative 4th zinc sulfate and 1 times 10 to the negative 2nd copper sulfate. Now it looks like we have a voltage of 0.907. 0.907. All right. See, what you'll notice is the voltage is reading 0. That's because we don't have the salt bridge to carry the charge in solution yet. So once we put the salt bridge in, record the voltage. Again, the voltage increased. We have a voltage of 0.963. We'll go 0.963. All right. So now we have the 1 times 10 to the negative 2nd zinc sulfate and 1 times 10 to the negative 4th copper sulfate. Voltage of 0. Wait. Oh. Yeah, let's just. All right. We'll do 1.004. Thank you. All right, so 1.012. All right. So this is the 1 molar zinc sulfate with the 1 times 10 to the negative 6 molar copper sulfate. So we have a voltage of 1.014. 1.014. So the last one is we need to get the measured voltage at standard conditions. So 1 molar of each of the anode and the cathode. So I'm just going to switch out the 1 times 10 to the negative 6 copper sulfate. And I'm going to use the 1 molar copper sulfate. So remember, we know what the voltage should be for this. The voltage should be 1.1. So the zinc with the anode, copper with the cathode. And the last thing is the salt bridge. So pretty close. Stable. So 1.075 volts. Perfect. So that's part 1. Alright, so the first thing we're going to do is we are going to record the voltage and the current from a piece of potato. The potato is the actual cell here, so we still need our copper cathode and our zinc anode. So we're going to hook up the red with the cathode and the black with the zinc anode. And we're going to record our first number that we see here, because as you're running it, it's constantly consuming, so it won't stabilize. So we are going to get the voltage for one piece of potato. So 0.863. Alright, so now we're going to switch it to an ammeter. Ammeter. So we'll start with microamps. So yep, 144.3 microamps. Now we're going to move on to the pickle and the vinegar. Alright, so now we are going to record the voltage and the current for a pickle. Copper cathode and the zinc anode. Let's get a fresh spot. Start with the voltage. 0.890 volts. So just do an ammeter and record the current. Oh, out of range, so we need to switch. So here we have the microamp setting, we need to go to milliamps. So 3.53 milliamps. Alright, so last one is the vinegar. So they're not touching. We have the anode and the cathode in solution. Now we'll record the voltage for vinegar. 0.942. So 0.942. Now we're going to make it an ammeter. Now I'm going to go right to milliamps. So 0.42. Alright, so now we can move on to in series and in parallel. First, 2 potatoes in series. So we want to have the anode and the cathode in each piece of potato. Now we need to use the alligator clamps. So in series means we go from the anode to the cathode. So we are going to go from the copper to the zinc. And now these 2 pieces of potato are connected in series. So now we're going to see what that does to the voltage and the current. We still want to go black to the anode. And we want to do red to the cathode. So now we have them hooked up in series. So let's see what happens to the voltage. The voltage is 1.928. So 1.928. So there was an increase in voltage when we hooked up the potatoes in series. Now let's check the current. Current for 2 potatoes in series, 178.3 microamps. Now we are going to do in parallel. So that is like to like. So we're going to go cathode to cathode, or the copper to the copper. Now we're going to do anode to anode. The zinc to the zinc. Now let's see what happens to the voltage in parallel. Alright, let me get back to a voltmeter. 2 potatoes in parallel. The voltage is 0.952. 0.952. Let me get an ammeter. And let's record the current. So 307.7 microamps. So you can see that in series increased the voltage, and now we have in parallel, and that increased the current. So that was 2 potatoes in series and parallel. Now we're going to do 3 to see if the trends stay the same. So since we already have the parallel set up, we will just move right to 3 potatoes parallel. Remember, parallel is like to like. So copper to copper. And zinc to zinc. So now we have 3 potatoes in parallel. So let's look at the voltage. So 0.948. So basically no change in the voltage when you have 3 potatoes in parallel. So now we are going to turn it into an ammeter and see what happened to the current. So 3 potatoes in parallel. So we are out of range for the microamp, so we have to go to milliamp now. So 0.51 milliamps, 0.51 milliamps, or 510 microamps. So the voltage stayed about the same, and the current increased again when you compare 3 potatoes in parallel to 2 potatoes in parallel. So it increased the current again. Now we're going to go to 3 in series. Alright, so remember, in series we go from the anode to the cathode. So we're going from the zinc to the copper. Same thing here. We want to go from the cathode to the anode. So now we have 3 potatoes in series. The red with the cathode, or the copper. And then the black. Oh, nice. The black to the zinc anode. Alright, so last time when we did 2 potatoes in series, we noticed an increase in voltage. So let's see what happens when we do 3 potatoes in series. 2.849. 2.849 volts. So it increased in voltage again. Now let's change it to an ammeter. And now 3 potatoes in series. Let's see the current. 186.3 microamps. 186.3 microamps. So no change in the current. So it looks like series increases the voltage and parallel increases the current in 2 and 3 potatoes.